We continue normal distribution. Now we find the mean deviation about mean of normal distribution. We obtain firstly the PDF. Okay, we have the PDF for normal distribution with parameters mu and sigma square as f of x equal to 1 by sigma root of 2 pi e raised to minus 1 by 2 x minus mu by sigma whole square minus infinity less than x less than infinity minus infinity less than mu less than infinity sigma greater than 0. Okay, now mean deviation about mean equal to expectation of mode x minus expectation of x or mu 1 dash, and for normal distribution also mu 1 dash equal to mu for normal distribution. Therefore mean deviation about mean, okay, mean equal to mu, mean deviation about mean equal to mu, that is equal to expectation of mode x minus mu. Okay, so that equal to integral over x mode x minus mu into f of x dx, as x is a continuous random variable, normal variate is continuous. Okay, so that is mean deviation about mean mu equal to integral minus infinity to infinity mode x minus mu into what about f of x 1 by sigma root of 2 pi e raised to minus 1 by 2 x minus mu by sigma whole square dx. Now for normal distribution, next step is the substitution step, z equal to x minus mu by sigma. Okay, implies what about here we need x minus mu equal to sigma z. Okay, so that dx equal to sigma dz. And also minus infinity less than z less than infinity as z equal to x minus mu by sigma. Okay, therefore mean deviation about mean mu is, what is it, integral minus infinity to infinity. Now mode x minus mu becomes mode sigma z, as sigma greater than 0, sigma is a constant, sigma taken out into mode z into 1 by sigma root of 2 pi, okay, e raised to minus z square by 2. What about sigma dz? Is it okay? Sigma mod z, okay, 1 by sigma root of 2 pi e raised to minus z square by 2 sigma dz. So one sigma cancels and the sigma taken out, sigma into, and mod z e raised to minus z square by 2 is an even function. So that we can write this as sigma by root of 2 pi into 2 into integral 0 to infinity mod z can be written as z e raised to minus z square by 2 into dz. Okay, now we want the substitution z square. The reason is since the integrand is an even function, of z, since the integrand is an even function of z. Okay, now we write the substitution z square equal to u. In order to proceed, we substitute z square equal to u. Let z square equal to u implies 2z dz equal to du. Okay, implies dz equal to, no, z dz equal to du by 2. Also, what about the limit? As z square equal to u and z is from 0 to infinity, 0 less than u less than infinity. That is mean deviation about mean as, what about What about sigma by root of 2 pi into 2 into integral 0 to infinity e raised to minus u by 2 into z dz is du by 2. Okay, into du by 2. So 2 cancels. Okay, that is sigma by root of 2 pi into simple integration e raised to minus u by 2 divided by minus 1 by 2 over 0 to infinity. Okay, simple integration e raised to minus u by 2 divided by minus 1 by 2. Now when we substitute the limits, we have e raised to minus infinity. E raised to minus infinity equal to 0 and e raised to 0 equal to 1. So we apply these results. That is, we have sigma by root of 2 pi into minus 2 into this 2 goes to the numerator. So e raised to minus infinity 0 minus e raised to 0 1. That is, root 2 remains here. That is sigma into root of 2 by pi. Mean deviation about minus sigma into root of 2 by pi can be approximated as 4 by 5 sigma, approximately equal to 4 by 5 sigma. That is mean deviation about minus 4 by 5 sigma. Okay, mean deviation about minus 4 by 5 sigma. Now the next is the quartile deviation of normal distribution. Quartile deviation. We know quartiles are those values that divides the total probability curve to 4 equal parts, and there are 3 such quartiles, Q1, Q2 and Q3. Okay, Q1, Q2 and Q3 are the we write quartile deviation. Of normal distribution. I will give a brief summary. There are 3 such quartiles, 3 quartiles Q1, 3 quartiles Q1, Q2, Q3 that divides the total area to 4 equal parts. To 4 equal parts. Okay, 4 equal parts, and there are 3 such quartiles Q1, Q2, Q3, Q1, Q2, Q3. We know Q2 as the median. Okay, which divides total area to 2 equal parts, and Q1. What about Q1? Below Q1 25% and above Q1 75%, and Q2 such that 50% below and above, such so that the 2 equal parts. And what about Q3? Q3 is such that below is 75% and above is 25%. So this is the history. 3 quartiles Q1, Q2, Q3 that divides the total area to 4 equal parts. Q1 is such that 25% below Q1 and 75% above Q1. That is, we take 25% below Q1, so that probability x less than Q1 equal to 0.25. And as Q3 is such that 25% above Q3, so that probability x greater than Q3 as 0.25. Okay. So here for normal distribution we have x. Let x follows normal means sigma square. Let x follows normal means sigma square, and we have Q1 and Q3 are the first and third quartiles. Q1 and Q3 are the first and third quartiles, which implies probability x less than Q1 equal to 0.25 and probability x greater than Q3 equal to 0.25, 0.25, okay. Probability x greater than Q3 equal to 0.25. Now we consider probability x greater than Q3 and we mark it using the normal probability curve. Okay, this is the normal curve which is symmetric at z equal to 0. I am drawing a rough figure. So that here 0.25, that is greater than Q3 is 0.25. Let me. So that here it is symmetric at z equal to 0 and this area is 0.25 greater than Q3 means greater than some point means that from that point up to infinity. So this area is 0.25. Now we consider the transformation. Let z equal to x minus mu by sigma. Okay, so that standard normal curve is symmetric at z equal to 0 and if we consider Q3 minus mu by sigma z greater than, that is probability which implies probability z greater than, let me write here, probability z greater than Q3 minus mu by sigma equal to 0.25. So that the area above some point is greater than 0.25. As we know, the standard normal is symmetric at z equal to 0. Listen to this point. As we know, standard normal curve is symmetric at z equal to 0. Probability z greater than 0. I will write here probability z greater than 0 equal to 0.5 and some point and above that point the area is 0.25 which implies that that point, that is this Q3 minus mu by sigma belongs to the right of 0. Once again I will explain. As we know z equal to x minus mu by sigma is symmetric and z is equal to 0, probability z greater than 0 is 0.5 and we are given, we have this probability z greater than Q3 minus mu by sigma equal to 0.25. So this point is somewhere to the right of 0 and let us take it as plus z1. Okay, that is let z1 equal to Q3 minus mu by sigma. Let z1 equal to Q3 minus mu by sigma. And hence we get, what about, and hence we get probability. So this implies probability z greater than z1 equal to 0.25. Z greater than z1 equal to 0.25. And we have the area in standard normal tables from 0 to any z. And we want this area. Therefore, probability 0 less than z less than z1 equal to 0.25. And from tables, we search for the z1 from tables. We will get the z1, the value of z1. It is obtained as 0.675. Okay. From tables, it is z1 equal to 0.675. Okay, that is this probability 0 less than z1 equal to 0.25. So we have the area or the probability equal to 0.25 and we want the corresponding set, the ordinate. Okay, so z1 is the area, z1 is the ordinate at 0.25, z1 equal to ordinate at 0.25. Ordinate at 0.25 equal to it is 0.67. Okay, 0.25 is here, 0.2518. The value is corresponding Z value is 0.6 plus 0.08, that is 0.68 corresponding to 0.68. The value or the probability is 0.2518. So more approximately we may write it as from table Z1 equal to, that is Z1 equal to 0.67. Let us write it as 0.67 or not exactly 0.68, or we may take it as more approximately 0.675. Okay, that is we have Z1 equal to, that is Z1 equal to 0.675. Now similarly we have probability X less than Q1 as equal to 0.25. Let me cancel all this and we go back. And we have probability X less than Q1 equal to 0.25. Now we consider probability X less than Q1. Now probability X less than Q1 equal to 0.25. That is probability Z less than Q1 minus mu by sigma equal to 0.25. Z less than Q1 minus mu by sigma equal to 0.25. So this is the area under the normal curve, and corresponding to this area is probability Z less than some point, that is from minus infinity to that point. So somewhere here. So this area is probability, this area is, or the probability is 0.25. And the corresponding area on the right axis we have also 0.25 we have already obtained, and it is, what is it? It is obtained as 0.675. Okay, that is this Q1 minus mu by sigma, that is Q1 minus mu by sigma equal to minus Z1, so equal to minus 0.675. Minus 0.675. Let me write on the next, on here. That is Q1 minus mu by sigma equal to minus Z1, and we have hence it is obtained as minus 0.675. Okay, now what happens now? Q3 minus mu by sigma minus of Q1 minus mu by sigma equal to, what is it? 0.675 minus 0.675. 0.675 is 2 by 3. Okay, so that Q3, that is Q3 minus Q1 whole by, Q3 minus Q1 whole by sigma equal to 2 into 0.675. 2 into 0.675. That is quartile deviation. Quartile deviation, what happens? Quartile deviation is defined as QD equal to Q3 minus Q1 by 2. Okay, that is QD equal to, what happens? This becomes here, so that sigma into 0.675 into sigma equal to 2 by 3 sigma approximately. Okay, 2 by 3 sigma. We have obtained quartile deviation as equal to 2 by 3 sigma. Quartile deviation is Q3 minus Q1 by 2. So it is 0.675 into sigma. Okay. So that equal to 2 by 3 sigma. Okay. Now one more point. Now we have mean deviation as a remark. We write mean deviation. Remark. Mean deviation is to quartile deviation is to standard deviation equal to, we have already obtained it as 4 by 5 sigma into here is to ratio is to 2 by 3 sigma is to sigma. That is what happens. That is 10 is to 12 is to 15. Sorry. As a remark, we write quartile deviation is to mean deviation is to standard deviation is quartile deviation is 2 by 3 sigma is to 4 by 5 sigma is to sigma. That is we get 10 is to, so 10 is to 12 is to 15. Okay. So that quartile deviation is to mean deviation is to standard deviation as 10 is to 12 is to 15. Okay. Thank you.